A block of mass m moves on a horizontal circle against the wall of a cylindrical room of radius r. The floor of the room on which the block moves is smooth, but the friction coefficient between the wall and the block is mu. The block is given an initial velocity v0 as a function of the speed v. Write part 1, the normal force by the wall on the block, the frictional force by the wall, the tangential acceleration of the block, and integrate the tangential acceleration dv upon dt equal to v times dv upon ds to obtain the speed of the block after one revolution. So here, when this cylindrical mass moves, then there will be a centrifugal force on this block. So we can say that centrifugal force is equal to normal reaction, which will also be equal to centripetal force. So we can write mv square upon r is normal reaction. Now, frictional force is equal to mu times normal reaction. So it will be mu times mv square divided by r. Now, we have to find out the retardation due to the frictional force. So we can apply formula ma equal to, let's write it as minus ma, mu times mv square upon r. So mm will cancel out and we will get the value of retardation or negative acceleration. That will be minus mu v square upon r. Now, this is answer to part A and this is answer to part B. In part B, the frictional force by the wall. So that is this. This is answer to part B. And in part C, the tangential acceleration of the block is to be found. So this value is answer to part C. So we can write here it as C. And now let's consider the next part. For that purpose, we take this A as dv upon dt, which is minus mu times v square upon r. But in our question, dv upon dt is given as v times dv upon ds. And it is true. So dv upon ds into ds upon dt. Here we have introduced ds. And that is equal to minus mu v square upon r. Radius we can write either capital R. So it would be Eg. Now, here ds upon dt equal to v. So v times dv upon ds equal to minus mu v square upon r, or we can take ds to RHS and other things to LHS. So ds will be equal to minus v dv times r divided by mu v square. So this will give minus r upon mu v and dv. Now we can integrate it. So we have ds equal to minus r times mu v dv. If we integrate it, so it will become s equal to minus r upon mu times log v plus c. In our question, it is given that when s equal to 0, v equal to v0. So if we put that value here, so 0 equal to minus r upon mu times log v0 equal to, plus c. So c will be equal to r upon mu times log v0. Now we put this value of c in equation number 1. So S equal to minus R upon mu log V plus R upon mu log V0. Applying property of log M minus log N is equal to log M upon N. So here minus R upon mu log V minus log V0. So this will become minus R upon mu log V upon V0 is S. But in our question, it is given that after one revolution, we have to find out the speed. So after one revolution, S equal to 2 pi R. So we put this value here. So 2 pi R equal to minus R upon mu times log V upon V0. We can shift these things to LHS. So minus 2 pi R times mu divided by R equals log V upon V0. R will cancel out. Now we can remove log from RHS. So everything will go in the power of exponential. So we can write it minus 2 pi mu equal to log V upon V0, taking exponential. So we know that e to the power log of x gives x. So here we will get e to the power minus 2 pi mu equal to V upon V0. Our concern is to get value of V. So V will be equal to V0 e to the power minus 2 pi mu. And that is our answer. Now let's go to next question. Next question says, a table with a smooth horizontal surface is fixed in a cabin that rotates with a uniform angular velocity omega in a circular path of radius r. A smooth groove AB of length L less than capital R is made on the surface of the table. The groove makes an angle theta with the radius OA of the circle in which the cabin rotates. A small particle is kept at point A in the groove and is released to move along AB. Find the time taken by the particle to reach the point B. Particle is here. It has to reach to point B. This length is L. We have to find the time. So the basic thing is to find the acceleration of this particle. So we know when this cabin rotates, there will be centripetal force and there will be centripetal acceleration also. So let's find out the force on this cabin. So force will be equal to m times capital R omega square. Suppose particle is here. So at this point, force on the particle will be mr omega square. But since particle has to move in this direction and this force is acting in this direction, so we have to find out the component of this force along this groove. So if this angle is theta, then force along the groove will be is equal to F cos theta. This force is acting in this direction. And we have to find out the force in this direction. So we can say it will be F cos theta. That is m r omega square cos theta. This is force on the particle. So we can easily find the acceleration on the particle. So ma equal to mr omega square cos theta. Mm will cancel out. And we will get the acceleration of the particle, that is a equal to r omega square cos theta. Now we can apply S equal to ut plus half at square. Here u equal to 0 and S is given as L. So L equal to 0 plus 1 by 2. Acceleration is r omega square cos theta times t square. Our concern is to get t. So 2L divided by r omega square cos theta under root will be equal to t. And that is our answer. Thank you for watching.